it turns out that there's a nice, clean criteria for checking whether or not a subset is also a subspace. And this is often given the name the subspace test, and that's what we'll call it. The subspace test says the following. If V is a vector space, okay, so V is a vector space, can't spell, vector space, and W is a subset, then W is a subspace if we're going to take our list of 10 items, and it turns out that we can whittle it down to 2 items. W is a subspace if it's closed under addition. So if for vectors U and V in W, okay, we have U plus V is in W. And if U is a vector in W and K is a scalar, then K times U is in W. Okay, so if the vectors in W are closed under vector addition and scalar multiplication, then it's a subspace. And let's think about why that should be. Okay, so let's think about why these two are the only two things that we have to check. And I want to go back to our list. Sorry, this is kind of a long way back here. But I want to go back to our list. So really, we said that just checking items 1 and 6 were enough. And the reason for that is that we know that W is a subset of a vector space V. And so by just by being in V itself, many of these things are true. Okay, so if you add 2 vectors, the order doesn't matter. Vector addition's associative. There's got to be a 0 vector. Okay, the reason why there has to be a 0 vector is that since the subset is closed under scalar multiplication, that means that if you take a vector and multiply by 0, you should get the 0 vector. And as we already showed in a previous video, if I take, and maybe I can just scroll up here, if I take any vector v and multiply by 0, we get the 0 vector. So that tells you already that the 0 vector is going to exist in W. So really all we have to check is items number 1 and 6, and that's enough to show that we have a subspace.